Hi, so today we're going to go over how to rewrite radicals, but when the radical is in the fraction. So radicals in fractions, that's called denominator. And there's 1,000 YouTube videos on this, but I wanted to go over it. You guys have our assignment today, which is based on this. So it's pretty much like this. If I were 1 over 2, that's okay. Easy to do, no problem. But if I write 1 over square root of 2, this is no way. You can't have a square root on the denominator. It's like leaving your pants down. You don't walk around with your pants hanging down. What we do is we multiply by, let's see, what can I multiply by a square root to get rid of a square root? Let's try a couple of things on the side. If I said, let's use red, square root of 2 times 2. Can a square root of 2 and a 2 multiply? Can a 2 affect the people inside the square root? We practiced before. We said no. This is 2 on the outside, 2 on the inside. What if I square it? Square root of 2 squared. Well, a square and a square root are inverse operations. They undo each other. Yeah, that gives me a regular 2. That takes the square root out. Another way of looking at the square root of 2 squared is us writing it this way. Square root of 2 times a square root of 2. This gives me a square root of 4. Hey, we know what the square root of 4 is. That's also just 2. So we have 2 methods. We have this one that works. We have this one that works. So, whoops, wrong check mark. We have this one that works. So what we're going to do here is we're going to multiply the square root by a square root of 2. If I do that to the denominator, we have to do it to the top. If you remember, when you multiply a number by itself, that's always equal to 1. So we're not changing the value like we mentioned in class. I'm changing the way it looks. Lead plastic surgery. This becomes square root of 2 over 2. Why? Because square root of 2 times square root of 2 is square root of 4. And square root of 4 leads me back to 2. Now we are done. This is okay. The square root is no longer on the denominator. It's on top. And I'm okay with square roots on top. I'm not okay with square roots on the denominator. Let's do another quick problem. 1 over the square root of 7. Okay. We don't like the square roots on the denominator, so we have to multiply by the same square root. Put top and bottom. 1 times the square root of 7 is 1 square root of 7, or we can just write it square root of 7. We don't need to write the 1. Divided by square root of 7 square root of 7. That's just 7, because square root of 7 times square root of 7 is 49. Square root of 49 is 7. Easy. Do I care about the square on top? Nope. I only care that if the square root's on the bottom, we have to fix that. Okay. Right? Big warning lights. Now, what if I throw some numbers around this? What if I write 1 over 3 square root of 5? Am I okay with a 3 in the denominator? We said before, yeah, that's not a problem. Just like the 2. But I don't want that square root of 5. Don't bring your friends in here, right, with their shoes. Take off their shoes. So we multiply the right side. You could multiply by 3, but just waste of time, waste of work. Instead, we are going to go slower. Instead, we're going to multiply by just square root of 5. Remember, you get to choose what you want to multiply. And if I say only the square root of 5, hey, a square root of 5 times square root of 5, it's a square root of 25. And we know what the square root of 25 is. That's just going to be 5. And 3 times 5 simplifies. 3 times 5 is 15. And we just move the square root on top. Now, let's try that again. Now, this could be any number. Let's say this is number 4. 1 over 7, square root of 2. Do I care about the 7? Do I just care about the 2? I care about the 2 because it's inside the square root. And since we don't want square roots inside on the denominator, we're going to multiply by square root of 2, both sides. A square root of 2 and a square root of 2 is really a square root of 4 because square roots always multiply square roots. Outside numbers never multiply inside the square root. So we're left with 7 times 2 over square root of 2. And 7 times 2 is 14. Can I reduce the 2 and the 14? Nope, because stuff inside the square root, it's almost like inside your house, doesn't play with stuff outside. Now, if we have some more examples here, what if I have square roots everywhere? What if I have square roots on the top and the bottom? The square root of 3 over 5 square root of, let's say, 7. What if I have square roots everywhere? What happens now? Are we okay with the square roots on top? Are we okay with square roots on bottom? So we don't want the square root on the bottom. Since we don't want the square root on the bottom, we multiply the square root on the bottom by a square root of 7 to the top and the bottom. Square root of 7 times square root of 7. We said that is a square root of 49. Well, please, you don't have to write square root of 49 because we know that we're going to get rid of each other and we're just going to be a 7 left over. On top, is 3 a square root? Is 7 a square root? Yeah. So square roots multiply each other. Okay. Why don't we bring up the 5? Great question. The 5 is on the bottom. You could multiply. Let me do the same problem with it, okay? That's a good question. I'm gonna write this in the red now. Let's do the same problem. And remember, it's up to you. You can make a decision what you want to multiply. If you want to multiply by 5 square root of 7, sure. You do that. And if we multiply 5 times 5 is 25. And 7 times 7 is 49. So this is 25 times, not 49, because the square root of 49 is 7. And it's going to be 5 on the outside, because there's an invisible 1 on the outside. Square root of 21. Now, we can multiply 25 times 7, but I want you to take a look here. Hey, doesn't 5 and 25 reduce? So even though we multiply 5 on top and the bottom, we were going to reduce anyways. So we could actually save time by not writing it. Okay, let me pause. So I was asked a question, what about square root of, let's say, 6 over the 2 square root of 3. I'm okay with a square root on top. I'm not okay with a square root on bottom. So we could multiply by 2 square root of 3, but we said, just like in our last problem, it's just going to cancel anyways. So let's not do that. Let's just multiply by the square root of 3 to the bottom and the square root of 3 on top. When I do that, this becomes a square root of 9, which is just 3. So the cool thing is that you can just skip and just write without the square root anymore. On the top, it's the square root of 18. But some of you guys might have seen that 6 is really 2 and 3. And we actually have a pair of 3's coming out. If you're not sure, on the side, let's check 18 is 2, 9, 3, 3. So it's really 2 times 3 times 3. Do you have any pairs? a pair of 3's. 3 square root of 18 over 6. Can we reduce? We can. We can reduce by 3. That's going to be square root of 18. Oh, I'm sorry, not square root of 18. I made a mistake. I cleaned up the 18 to become 3 on the outside and 2 on the inside. I'm sorry about that. And we're reducing the 2 and the 3. That becomes a 2 on the bottom. Now, this is one way of doing it, which is 100% okay. But here's something that we learned about before about dividing. If I'm dividing a radical, I could have divided the 3 from the 6 also, because they're both in the square root. This could have already be written as 6 divided by 3 is 2 over 2. Same answer, but faster. So we have a lot of tools, a lot of tricks that we can use to finish these problems. And that's it. Your worksheet today, you guys are going to be not worksheet, I'm sorry. You guys have a multiple choice on Schoology, and go ahead and try these problems. There are about 10 questions, and they're made up of questions like this. Okay. Let me do one more, just one last one. 7, let's pick a big number. The square root of, let's say, 18 divided by the square root of 6. If I don't see how to do the problem, we're going to go ahead and multiply by the square root of 6, because I don't want the square root on the bottom. Square root of 6, square root of 6. This becomes, hey, that's out, and 6 times 18 is a big number. That's 60, and that's 48. That's 108 in the square root. Now you want to simplify the square root. 108, 2, 54, 2, 27, 3, 9, 3, 3. Have a pair. We end up with a 6 on the outside. Left over the 3 over 6. Hey, I can reduce this. That becomes square root of 3. Now that seems like a lot of work, but you practice it, we get better at it. We'll be doing this all the way through high school and into college. Now, some of you guys might have been screaming at me and saying, Mr. Ko, can't we divide 18 and the 6? And because they're both in square root, yes, we can. We can divide 18 by 6. We can write them as a big square root. That becomes just 3. That would have been faster. What if there's a negative sign on the fraction? Negative sign on the fraction, on the denominator, that's fine. You can leave it in the denominator. But the negative sign can never be inside the square root.